Okay, let's finish up 7.4. So I'll call it 7.4b. So we just went over the homework, so you already know. But what was the first special type of triangle?
45, 45,
Yeah, so the first one, I'll write it up here. 45, 45, 90. Or some people just say 45, 45 right triangle, but I usually say 45, 45, 90. Keep them all numbers, right? All right, and I gave you a little sneak preview yesterday. Just told you what it was. I didn't tell you anything about it. But what was the next triangle? Do you remember? Good. 30, 60, 90. All right. So guess what that means? You should have a general idea what that means at least. What does that mean?
30, 60, 90.
Yeah, but what does the 30, the 60, and the 90 mean? What are they? Yeah, the length, not the lengths.
That's the angles.
It's the measure. We say when we talk about an angle, we talk about the measure of the angle, okay? So the angles, right? So there's my 90, right? Which one do you think is the 30? The top left or bottom right? Bottom right, yeah, because that's smaller. And this is 60. Now, here's another way to remember it. We talked about this. Guys, we've started. So we talked about this in another chapter. I think chapter 5, because I'm teaching this in my other CP class. Which one is the longest side of this whole entire thing? The longest side?
The left side, the hypotenuse.
The hypotenuse. Very good. So give me a line segment, AC. Right. So AC is the longest side. Why do you know it's the longest side? Just because it looks like it? It's not a really good way to do it, because it's across, or we say opposite. All right, but across, same thing. Okay, it's across from, or it's opposite the 90-degree angle. All right, because that's the biggest angle. So the side opposite the biggest angle is the biggest side. You with me? So that means which one's the shortest side? Not just because it looks like it, but give me a good reason. AB. Why is that the shortest side? Because it's opposite, and I'm going to actually call that. Now, I'm not going to call it the side. It is a right triangle, so I could call it a what? A leg. So it's the short leg. All right? This is the hypotenuse. All right? And this is going to be called the long leg. Very good. All right? Everybody with me on that? All right, so this is the long leg. Does that mean this is the longest side? No. Okay, the hypotenuse is always the longest side on a right triangle. But this is the longer of the two legs. We got it? Okay, you got to know that. All right, before we do what we're going to do. Yeah, I don't think I'm going to do that. I got all this stuff. I don't know. Do you want to see it or not? All that? You do?
No.
Yeah. No, it's just gonna show you where we get these equations from. You just want to know the equations? Know the formulas? Just want to know the formula? All right. All right, since this is a shorter day, we'll just write them down. But if you really want to know where these come from, I could show you. It's all right here. It's kind of interesting, to tell you the truth. But I'm just going to write down what it is. So, do you remember when did the 45, 45, 90? You only had one leg, right?
Yeah.
Well, you had two legs on a 45, 45, 90 triangle, but what's true about both legs? They're the same. They're equal to each other, okay? So you didn't just have one leg, but you just called it the leg. It didn't matter which one, but it does matter which one here, okay? It matters if it's the short one or the long one. Everybody got that? So what happens is we are going to relate the hypotenuse to the short leg. And then we're going to take the long leg and we're going to relate it to the what? Short leg. So the short leg is the one that's really important, okay? Both things relate to it. So when we did 45, 45, 90, the hypotenuse was how much of the short leg? I'm sorry, of the leg.
What?
Half. No, half.
If I had a
2 times the square root.
2 times the square root,
What's times?
you're saying right words, but not in the right order, okay? Watch. What if you had this, okay, and that was 5. What's this?
5 times square root. 10.
It's 5 times, it's not 10. It's 5 times the square root of 2. We spent all class period, not all class period, but a lot of class period yesterday showing that this hypotenuse was always the square root of 2 times the leg. Everybody see it? So on the 45, what did we write down? Look in your notes. We wrote what? Hypotenuse is equal to what? The square root of 2 times the leg. We put it in a box and everything. Would you agree? Yeah, we did that yesterday. We're going to do the same thing today, except instead of just having one little formula, one little equation, how many do you think we're going to have now? 2, because I got a short leg and what? A long leg, all right? So I need an equation for both of those. You got it? All right. The thing is, they both relate to the short leg. So the short leg is super important. I'll show you what I'm talking about now. So this is for 30, 60, 90. I'll write it right here so we don't. 30, 60, 90. All right? Here's the thing. This is what you're going to have to memorize. You're going to have to know this. So the hypotenuse, now again, I could go through and show you why this is true, but I don't think many of you will really care. All right, so whether or not you care, I probably should show it to you. If you were probably if you're in an honors class, I might go through the whole thing and show you why this is true. It may be on one of my honors videos if you really want to watch, but I'm just going to tell you what it is. The hypotenuse is exactly 2 times the short leg. All right, Matthew, you said that for the 45, okay? So it's not completely untrue. It is untrue about a 45. But on a 30, 60, 90, the hypotenuse is exactly twice the short leg. All right, so that's one thing you need to know. So that's pretty easy. So what if the short leg was 3? What's the hypotenuse? It's 6, that's right. Okay, what if I told you the hypotenuse was, I don't know, 14? What if the hypotenuse was 14? What's the short leg? It's 7. Everybody good with that? Where are you guys going? Baseball? Where are you going to be? Oh, it's here? I might, because I think lacrosse plays too, right?
Yeah.
Is lacrosse leaving too? Is there anybody going to be left in my room? Actually, I wasn't collecting that, but because I'm going to collect it tomorrow. Because, here, take these back. Everybody take these back. Because you weren't able to do them all. You weren't able to tell him. Okay. So give those back because I want you to try the 30, 60, 90 problems, okay? Because remember, when I read them off, I only read off half of them, less than half of them. So do the 30, 60, 90. Watch the video. You guys watch the video. Learn about 30, 60, 90. And finish up that homework and turn it in tomorrow. Okay, here we go.
Tristan's the only one that cared.
It does seem. That's all right. At least I said it. They can't say that I didn't tell them. All right, so now, here's another thing. Remember, they both relate to the short side, correct? So what do you think we're going to start this off at? I'm not going to write hypotenuse equals. What am I going to write? Because they both relate to the short side. So the hypotenuse is twice the short side. The what? The something else is something times the short side. So what is it? Nobody? I know. I probably didn't explain that question very well. What does he need? Let him in. Let him in so you know what he wants. This is taking too long. Somebody open the door. You're up.
Matthew, did that fall really good? You had that much?
All right. We're officially out of control now.
Can you see my charger? Yeah, I'll find it.
All right.
Oh my.
I didn't say, oh my.
All right, can we continue? All right. We got all the sports people out of here, so now we got the real students in here now, right?
Yes.
Now you can learn something. All right, so the long side, I'm going to give you this number, and if you really want to know, again, for like the 3rd or 4th time today, if you really want to know, I can show you how you get this, okay? But it comes out to this. It's the square root of 3 times the short side. It's very similar to the 45, okay? Except it's not the square root of 2. It's what? It's the square root of 3. And we're not finding the hypotenuse with the square root of 3. What are we finding? The long leg is equal to the square root of 3 times the short side. So the easiest version of this problem is going to be when they give you what? What do you think? If they give you one of the 3 sides. Which one do you think is going to be the very easiest that they could give you? The short side, right? The short leg right here. Okay, so for instance, what if they give you that to be 3? Now let's make it a different number. Whoops, what in the world was that? Let's try this again. I got to hit that button. Let's get rid of that. Okay, so let's say it's 5, all right? Because I don't want too many 3s floating around, all right? So let's say that's 5. What's the very easiest thing to find right now? Okay, and it is actually kind of easy, but I would say the hypotenuse, right? Because what do you have to do to it? Just double it. So what's the hypotenuse? 10. Okay. Actually, that might be just a little bit, not harder, but a little bit more involved than finding the long leg, because I actually had to do some multiplication. I had to know what 5 times 2 was. Okay. The long leg is actually not that hard, because the long leg is what? It's just 5 squared of 3. That's right. You just put that 5 next to a square root of 3, and that's it. You see what I mean by it might be a little bit easier? Now, a lot of people don't think that because they hate square roots, right? Just like fractions. But I tell you what, once you work with square roots and you start learning the rules for square roots, which you'll do in Algebra 2, you're going to learn a ton of different rules for square roots. Not just square roots, but any root. But you'll be doing a ton of square root stuff. And it just becomes so familiar, it doesn't even bother you anymore. But I know when you first see it, it looks weird, right? You're not really exactly sure what it means, even though you kind of do know what it means. Anyway, that would be the answer for the long side. Okay, so if they give you the short side, the other 2 are really easy. Would you agree with that? Yeah, I'm not just saying that because I'm the teacher. You do agree, right? If they give you the short side? Yeah, they give you the short, you double it to find the hypotenuse, you multiply it by square root of 3 to get the long leg. All right? And that's not that hard. You just go 5 times the square root of 3. Let's clean this up without all this mess around. Let's do an example. I'll tell you what, before I go to the example, let me do something else. We'll do this. We'll do this. Now again, this stuff is only true with what kind of triangles? But not just any right triangle. What kind of special right triangle? There's 2 special right triangles. 30, 60, 90. That's right. Okay. So if that's 30 and that's 60, then the stuff we just said would be true. Here's the second hardest part. Okay. That was the easiest. If I give you the short side, it's really easy to find the other ones. Okay. This one's just a tiny little bit harder. Not much at all. Just a little bit. So what if they give you this? What if they said that this was 12 and they ask you to find the other 2 sides? Yeah, so the short side is 6, right? That wasn't much harder than multiplying by 2, right? We just divided by 2. So if I know the hypotenuse, the short leg, is half of the hypotenuse. Everybody see that? Because if I knew the short leg, then the hypotenuse was twice the short leg. If I go the other way, then I just do what? Divide by 2, right? Now I know the short side. The long side's not hard at all. It's 6 squared of 3. That's it. That's all there is to it. If you don't believe me, do you believe me? You sure? Well, you're very trustful. If you didn't believe me, you could do a little math to see if that's actually true. What kind of math could you do that we've learned very recently in order to see if that's actually true? So we didn't really do a proof. I didn't show you why this is square root of 3, okay, or why this is double this, but let's do that. Let's do Pythagorean theorem, and actually, this is just for fun, all right? And we're going to see if this actually works. So what am I going to do? A squared, 6 squared, plus what? 6 square root of 3. Now watch very carefully. Again, I know you're pretty new to square roots, but if we square that, we got to square the whole thing, okay? Equals what? 12 squared. Everybody good with that? All right, let's do the math. 6 squared, 36. Now, let's do this one. What do I have to square here? Just the square root? I got to square root the 6 and the square root. So 6 squared again is what? 36.
Square root of 9?
No.
Don't they cancel each other out?
Well, they do. This square root cancels with that, so what am I left with? A 3. What is the 36 and the 3 doing to each other? Adding? Look at this 6 and this square root of 3. They're multiplying. There's no addition or subtraction in between. That means they're being multiplied. So when I square them, 6 squared, what? Times square root of 3 squared. And you're exactly right, Taylor. The square cancels out with a square root, so I'm left with a 3. So I got to multiply those together. I'll do that in a second. Equals, you know that in your head. What's 12 squared? 144. Okay? Everybody with me on that? So I should be able to do that in my head. 72 and 36, 108. Did I do that right? Let me just make sure. 36 times 3. Yep, I was right. Look at that. 108. So I did that in my head. So watch. 36 plus 108. Let's see. I should put a question mark here. Anybody listening? Okay. So look, I want to see if they're actually equal to each other. All right. And what's that? That's 14. Carry the 1. 3 and 1 is 4. Yep, it works, doesn't it?
I said we do another one.
Okay, so it does work. You're not going to have to do that on a test or anything. We just did it for what? For fun. Wasn't that fun? Wasn't it? All right, so I just wanted to see if this really works. So do you tend to agree with this whole 30, 60, 90 where this is twice the short and it's a square root of 3 times the short? Yeah, you should, because if it works out like this, and you could do it to other ones too and see if they work. All right? Now, what do you think is the hardest situation? Let's do this. Let's use the numbers that we just used so we know what the answer should be. All right? So that little dot right there is bugging me. Get rid of that. All right. So what if they give you the long side? I'm going to write them down again. What's the hypotenuse equal to on a 30, 60, 90? Should have it right in front of you in your notes. 2 times the short leg. Yep. And what's the long leg? Square root of 3 times the what? Times the short. Okay? Remember, they both have to do with the short. So the short one is the one that's super important, isn't it? Okay? Can somebody open the door, please? All right. So let's keep this in mind. So what do we want to find? Do we want to go right to the hypotenuse? Do I want to go right to the hypotenuse? Absolutely not, because look, I don't have anything that relates the long side to the hypotenuse, do I? No. So what do I want to find? I want to find what? The short side. Once I find the short side, I just double it and I get the long side. Easy. But how do I find the short side? We'll call that x and we'll call that y. All right? How do I find the short side? Well, let's use this one. Because they give us the long and you want to find the short. So let's do the math. What is the long side in this triangle? What's the length of it? 6 square root of 3. Not by 6 square root of 3 or 6 times the square root of 3. Or some people say what? What did I say that some people say? It's a lot shorter. 6 what? Root 3. Okay? Some people just say that. 6 root 3. I don't like that because you don't know if it's a cube root, a fourth root, a fifth root, or a square root. So I say 6 square root of 3. Anyway, let's keep going. 6 square root of 3 equals what? Let's fill in this. What's the next thing I write down? What's the next thing? Come on, everybody look at it. Everybody should see this. I already wrote down the long side. I'm just putting stuff in for this. What's the next thing I put in?
Take the square root away?
No, I'm just filling stuff in. I'm getting frustrated. I'm sorry. I'm just filling stuff into this little formula right here. Okay, the next thing I put is just a square root of 3, right? I put in a number for the long side, then I put in equals, and then what do I put now? Just a square root of 3. Do we not see that? Or I don't know. I don't know how else to explain that. It's just right next to it. You just put it in there. And now I put in this. What is this one?
6.
The short leg. Where is a 6? There's no 6 anywhere. I know what you're thinking. You're thinking of the answer, but you're not answering my question. All right. The short side. What's the short side? It's x. Okay. Everybody see that? So all I did was just plug in all the stuff to my little formula. Let's put the desk down, please. I just stuck everything into my little formula. That's the long side. Put in equals, put a square root of 3, put whatever the short side is. Now I just have to do really easy algebra. It's very easy. How do I get x by itself? Divide by what?
3.
It's not a 3. It's a square root of 3. It's not a 3. I don't see a 3 there, do you? Nope, because it's under a what? It's a completely different number. Okay, square root of 3 and 3 are completely different numbers. So you cannot say 3. I know what you're thinking. Mr. Hamrick, sure looks like a 3. It's just sitting under that little thing. All right, but it's not a 3. It's a square root of 3. So what do we have to do? Divide by the square root of 3. Come over here and do what? Divide by the square root of 3. Very good. Now what happens? Very easy math. What happens? Cancel each other out. That's right. Square root of 3 cancels out with that square root of 3. And what are we left with? X equals 6. All right. So anyway, that's what we can do. That's what we do. All right. I'm going to do one more and then this is 12. That's easy. Hardly have to think about that one. You with me? So if they give you the long leg, how do you find the short leg? You do what? What did we do? What'd you do? You divided by the square root of 3. Okay, so if they give you the long leg, you divide by the square root of 3 to get the short leg. And then once you get the short leg, that's easy. What do you do to get the hypotenuse? Just double it. Multiply by 2. Okay? There's one other version that's a little harder than this. A lot of people would look at this and say, oh man, this is real hard because they give you square root of 3. But it actually works out real nice and easy, doesn't it? Because the square root of 3's cancel out. Yes? Anybody here? You guys are like daydreaming a lot today. What's going on? Come on, pay attention. Focus. So let's do another version of this. Let's get rid of this. Let's get rid of this. Let's get rid of this. All right. Get rid of all this mess. Let's get rid of all this. And then I'm going to get rid of this mess. Guess by the time I do all this, I probably could have just rewritten it, couldn't I? But I've come this far. Is that us already? You kidding me? I've given you enough already. Let's do one more real quick. Watch. What if I gave you this and I said this was 5? How would you find this? I'm going to do it fast. Just watch. It's 5 divided by what? The square root of 3. But can you leave it like that? Let's do it over here off to the side. Can you leave it like this? No. Here's something we learned yesterday. If you multiply by the square root of 3 over the square root of 3, remember we can do that? All right. Because this is a 1. And let's do the bottom. What's square root of 3 times square root of 3? It's 3. What's 5 times the square root of 3? It's just 5 times the square root of 3. So that's what this is. It's 5 square root of 3 over 3. That's simplified. How do I get this? I just do what to this short side? I double it. So really all I got to do is multiply this by 2. So 2 times 5 is 10, and you just leave the other stuff the way it is. So that's the hardest version of this kind of problem. All right, finish up 1 through 16, okay? Everybody hear me? Finish up 1 through 16, and we'll review for the quiz tomorrow.